Our next problem is cot A minus cosecant A whole square is equal to 1 minus cos A divided by 1 plus cos A. So consider LHS. So our left hand side is having cot A and cosecant A, whereas right hand side is in cos A. Identities for cot A and cosecant A, just convert this cot A and cosecant A in terms of basic trigonometric ratios like sin A and cos A. So here I want to write cot A as cos A by sin A minus cosecant as 1 by sin A whole square. So which will be turning as, so inside you have LCM sin A, so it is sin A, on top you have cos A minus 1 whole square. So cos A minus 1 whole square, cos A minus 1 whole square, I can write like cos A minus 1 into cos A minus 1 divided by, here it is sin square A. So I am following A by B whole power m is equal to A power m by B power m formula. So with this I have distributed this square to both terms which are in numerator and denominator. And here sin square A I can write 1 minus cos square A, which will give cos A minus 1 into cos A minus 1 whole divided by, you have 1 plus cos A into 1 minus cos A. So this one and this one gets cancelled and you will have 1 minus 1 as the factor, and if you bring this minus 1 inside this function, you will have 1 minus cos A divided by 1 plus cos A, hence the RHS. The main point is converting the exact ratios and use the exponent laws, and then you will get the result. Our next problem is cosecant A minus 1 divided by cosecant A plus 1, which should be equated to cos A by 1 plus sin A whole square. So consider the LHS. In LHS you have 1 by sin A minus 1 divided by 1 by sin A plus 1, which will give 1 minus sin A by sin A whole by 1 plus sin A by sin A. This sin A gets cancelled, so you'll have 1 minus sin A in the top and 1 plus sin A in the below. So if you see the resultant, like if you see the RHS, below we have 1 plus sin A, but you need whole square. So multiply 1 plus sin A on numerator and denominator, which will give 1 minus sin square A, because by multiplying these two you will have 1 minus sin square A, like A minus B into A plus B will give A square minus B square. So here also you will get 1 minus sin square A. Below you have 1 plus sin A whole square, which will give 1 minus sin square A can be written as cos square A. So cos square A by 1 plus sin A whole square. I am taking the square for the whole term, like cos A by 1 plus sin A whole square is the RHS. Our next problem is tan square A minus tan square B is equal to sin square A minus sin square B divided by cos square A into cos square B. So here also we can take the LCMs by converting this tan into sin by cos, like converting tan A like sin square A by cos square A minus sin square B by cos square B. By taking LCM you will have sin square A into cos square B minus sin square B into cos square A. So this will be multiplied with this and this one with this. And in denominator you have cos square A into cos square B. But this is not the resultant one. So you need to take out this cos square B and cos square A in numerator. Then only you can reach to the right hand side. So you have, so I want to convert this cos square A. I want to take out this cos square A using the identity. When you convert this cos square A into identity using identity, it will become sin square B. So I want to write sin square A into 1 minus sin square B. I want to write cos square B as 1 minus sin square B using identity. Minus, this is sin square B and cos square A, I can write 1 minus sin square A whole divided by cos square A and cos square B, which is equal to, so I want to multiply with this. So sin square A minus sin square A into sin square B, and this one minus sin square B minus into minus plus sin square B and sin square A whole divided by cos square A cos square B. So these two terms gets cancelled because it is a sin square A and sin square B, both are same, so I can cancel. Now the remaining thing is sin square A minus sin square B divided by cos square A into cos square B, and the RHS. The main turning point is converting these cos terms into sin terms in the numerator. Our next question is sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta, which should be equated to tan theta. Till now we did only sin square form problems or cos square problems, but we have cubic term here. So here you see in the numerator we have sin theta as common in those two terms and even cos theta in denominator. So let us take the LHS and take the common thing like sin theta, which will give 1 minus 2 sin square theta whole divided by, here if you take cos theta as common, you will get 2 cos square theta minus 1, which will give tan theta into, so I want to split this one, but there is no way. So I want to write 1 as sin square theta plus cos square theta minus 2 sin square theta, and in below we have 2 cos square theta, and minus 1 I can write sin square theta plus cos square theta, which is equal to tan theta into, you have minus 2 sin square theta and plus sin square theta, so you have cos square theta minus sin square theta in the numerator divided by, in the below, 2 cos square theta, this is minus sin square theta minus cos square theta. If you bring this minus 2 inside, you will have this, but here 2 cos square theta and minus cos square theta, so on a whole you will have tan theta into, on top you have cos square theta minus sin square theta divided by below also, so 1 cos square theta is the remaining here and a minus sin square theta. So these two gets cancelled, the remaining thing is tan theta. The main turning point is writing this unity in terms of sin square theta plus cos square theta. That is the main turning point here. Our next question is sin A divided by 1 plus cos A should be equated to cosecant A minus cot A. So here in the RHS term you have cosecant and cot terms, and LHS you have sin and cos. Consider RHS here. Okay, I am considering RHS because that is the ratios we can convert into sin and cos. So sin RHS is equal to cosecant I can write 1 by sin A, cot I can write cos A by sin A, which is equal to, on taking LCM, you will have sin A in the denominator and on top you have 1 minus cos A. So you're quite reverse to the goal that you have to reach. So first of all, multiply with 1 plus cos A divided by 1 plus cos A, because the term that we need to prove is having 1 plus cos A in the denominator. So I am just taking that, which is equal to, you have 1 minus cos square A, like A minus B into A plus B can be written as A square minus B square. So on top you have 1 minus cos square A, on top you have 1 minus cos square A divided by, this is sin A into 1 plus cos A, this one. And we have 1 minus cos square A can be written as sin square A using identity, and divided by, this is sin A and 1 plus cos A. Sin A and 1 sin A gets cancelled, so remaining thing is sin A by 1 plus cos A. This is easy.